Thanks for sticking with us. The next conversation with science is going to be led by Lauren Chin, Impact Coordinator at the University of Edinburgh. So I'm going to welcome Lauren to the stage, who's going to talk to you a bit about the Climate Innovators Initiative that she's been working on with the Climate Desk team, and our scientists will be with us shortly. Thank you.
Hello. Hi, yeah, lovely to be here, and thank you so much for everyone for coming out today. It's great to see so many faces, so many curious and exciting people. So yeah, I'll give you a little bit of an overview about what the University of Edinburgh has been doing in partnership with Kite Insights and New York Times, something I'm so delighted to talk a little bit about today. The first is the Innovators Initiative, which we're really proud to present over this programming. The University of Edinburgh has partnered with Kite Insights and the New York Times to select and bring you a really diverse and wonderful group of innovators. Over the course of the programming, we have 3 really fantastic sessions with our finalists who went through some rigorous academic vetting. We've been selecting people from over the world, telling us what they're doing in moonshot inventions, systems change, and what they're doing to bring their innovations to fight against climate change. So I hope you'll be able to tune into that a bit. And the University of Edinburgh, we were so excited to be on board, to be a partner in this initiative, and to really spark change and impact through our work. So that's a bit about us and about University of Edinburgh. I would actually like to turn it a bit to the audience if you have any questions about what we've done or how you're feeling about COP26 at the moment, while we wait for Alan, who is here. So maybe we'll save that till the end.
No worries.
Why don't you take a seat right over
Okay,
here, Alan?
thank you.
Yeah, thank you so much for joining us today.
Managed to get caught up in the march, so here we are.
Well, thank you very much for taking the time today. And I'm delighted to introduce a little bit about Alan. So thank you again for coming out. How was the march?
Nationalistic, I think. I'm for both causes, so that's not such a bad thing. Viva Scotland. Viva Scotland. And Wales.
Absolutely wonderful.
Sure.
So yeah, if we could get started, you're a scientist and a glaciologist, if I'm saying that correctly.
Glaciologist, yeah, for sure.
Glaciologist. And your research investigates the links between ice, oceans, the atmosphere, and climate change. And I've heard you've explored some pretty neat areas between Antarctica to Alaska. If you could talk a little bit about that and what your path has been as a glaciologist.
Sure thing. Well, I started life off studying PPE, or Politics, Philosophy, and Economics. Yep. And I just got very disillusioned with human beings really early on and thought actually studying the natural environment would be a much more fruitful and positive experience for me. So I was very thankful for a professor in Edinburgh University, David Sugden, who has a joy for glacial landscapes in Scotland in a way that was very contagious. I mean, this was a long time ago. But thankfully, he took me on and rescued me from my world 30 years ago. And here I am today, still very passionate for the icy world, mostly Greenland, but also Antarctica, Patagonia, where I started my PhD studies, and everywhere in between, which is cold, basically. So
very opposite of where I'm from with warmth. And if you could give us maybe a short introduction on what is happening to the glaciers and the ice sheets at the moment, considering the vital role that they do play in climate change.
Well, they're melting, basically. Ice sheets in Greenland and Antarctica are moving faster, so they create more icebergs at the same time. So we call those dynamic losses. But effectively, they are responding to a warmer ocean and a warmer atmosphere at a rate that is, I keep saying this, flabbergasting to me. I grew up with school textbooks. I mean, we've probably all done a bit of glacial processes or moraines and stuff like that. And my geography teacher, 40 years ago, once said my progress in geography was glacial. I think he was making a joke at how crap I was at really getting with the plot back then. And so we use ice ages and glaciers as a metaphor for slowness. And what I think I've seen in the last decade, working in Greenland especially, but also in the European Alps, Antarctica, Patagonia, is that the rate of change of these systems is just mind-blowing, I think. I mean, I went into this because I love these landscapes. I didn't go into this as a climate scientist or an activist. I just love the idea that you have these huge reservoirs of frozen water that are moving through the landscape of these high elevation, high latitude areas, and eroding the landscape and leaving this indelible mark, as we see if you look around you in Scotland. I hope you all get to northwest Scotland to have a look at it all. But that was my interest, that was my excitement. And to sort of see them responding in the way that they do now, it's heartbreaking, but also, mind-blowing. I can't put it any other way. Trying to write dry academic papers about these processes and the rate of change that they're working, but effectively the textbooks that I grew up with have to be rewritten.
Right, and to maybe dive into a little bit more of the details, I think a lot of people, myself included, get the melting of sea ice sheets, and glaciers conflated. They sort of mix them up at times. Would you be able to elucidate a little bit for us and make that a bit more clear?
Maybe, I don't know. Okay, Glaciology 101. Sea ice is it's the frozen cap of sea ice because the atmosphere is cold. Obviously, sea ice has salt in it, so the sea freezes lower than just freezing. But in the way that a freshwater pond freezes over, sea ice will freeze below -5 degrees centigrade when those conditions are prolonged. And that's what's going on every winter across the Arctic, the Antarctic, and cold places across the north. And if you're cold enough, that sea ice perpetuates year to year, and that's what we call multi-year sea ice. And it's winter sea ice because it's cold up north, and multi-year sea ice that has declined so massively over the last 40 years. I work and live in Tromsø, northern Finland now, just inside the Arctic Circle, and the sea north of there, the Barents Sea, 40 years ago in the 1970s, it mostly froze over with sea ice every winter in the 1970s, 1980s. It's now almost ice-free in the winter. And that has a huge impact on the amount of moisture, the amount of energy that is put into the environment and into the atmosphere, and feeds moisture into Europe. So it's a new source, just like the Gulf Stream and the Atlantic is a source of why it's so wet today here in Glasgow. That is introducing a new source of water for Central Europe. Ice sheets and glaciers, that's the impact of, that is frozen fresh water sitting on land because snow falls and accumulates, and if it's not warm enough, it just keeps on accumulating. It's compressed, and it forms glaciers and ice sheets that just eventually flow like jam, like honey, under their own weight downhill. As I said, Scotland is a beautiful example of this because just 12,000 years ago, there was an ice sheet sitting over Scotland, and that sucked water out of the sea and reduced sea level. 20,000 years ago, sea levels were 120 meters lower than they are today. the Ice Age came to an end. Most of the ice, terrestrial ice that was sitting over North America, Patagonia, Eurasia, melted, sea levels went up. And we were left with these two ice sheets up in Greenland and Antarctica, and now those are now under threat because of anthropogenic warming over the last century.
And something I think that I've seen in my studies and heard that really surprised me was actually the fact that water vapor itself was actually considered a greenhouse gas emission in terms of what was happening. If you could talk a bit on that.
Okay, so there's lots of feedbacks. I mean, wow, you're hitting me with so many different questions. This is really real geography here. There's lots of greenhouse gases, not just CO2. We hear about carbon dioxide. It's an obvious output of burning fossil fuels. But there's methane, unoxidized, effectively, hydrocarbons that are coming from a multitude of sources. And then there's water vapor. And these are all feedbacks that tend to positively amplify the effect of a warming atmosphere and a warming ocean. So water vapor, so the warmer the atmosphere gets, the more vapor it holds, the more water it holds. That's why we have more extreme rainfall events, more extreme moisture events, hurricanes, whatever, monsoons. And they become more erratic, far more predictable, or far more constant, and at the same time that vapor in the atmosphere, like increasing methane, like increasing CO2, traps in heat.
Right. And I feel it's so interesting the fact that we really think of the Arctic and Arctic ice in general as things in cold areas, but they seem to, it sounds like, have effects in the global south in warm areas. Because of these natural processes that they amplify. Yeah,
I mean, the idea that the Earth's a interlinked system has been going on for decades. I mean, it's had its revelation in Gaia theory and Lovelock back in the 1970s. And though we sort of think of it, of those ideas as a bit of a hippy-dippy kind of idea, because the Earth, Mother Earth might heal herself. If you just look at, like, any mechanical system, it has inputs and outputs, and you can start to isolate those. It's how we conduct science on these systems. And so effectively what we're seeing is that, is that all of these things are interlinked. You can't,
right.
Like the Arctic and Antarctica are a massive cold sink for the heat that arrives on Earth. And that heat sink, it works through the transport of ocean currents and a huge amount of heat in oceans that, as I say, the Gulf Stream passes across the eastern Atlantic and feeds this. And we assume that these areas are cold enough to be able to take that heat out of the system and keep the Earth in equilibrium. When that system, I'm not going to say it goes wrong, because for sure on geological timescales, the Earth has seen every possible reconfiguration of its atmosphere and ocean, from the point where we think it was completely frozen over to the point, 60 million years ago when dinosaurs were roaming on the Earth and the Earth was 20 degrees warmer and there was no ice on it at all. The Earth has just seen everything. But in terms of the stability of the climate and the planet over the last 10,000 years since the last ice age, what I would call geologically the Holocene, but I think it's no coincidence that, it has been the dominance of humans, because we've had a stable, temperate climate which has allowed agricultural systems to develop and the like. That stability is, I think, unique to our era now, this last 10,000 years. So when we put these things into context, what we're now doing is shifting out of a climate, ocean, atmosphere, ice system in which we have a relative stability into a time of almost major instability, and that is very detrimental to society.
And I'd love to jump on that point. You're saying society, so what impact is this having on the non-human world, on biodiversity and society as well, outside of these greenhouse gas emission effects?
Outside of human society, it's tragic, the devastation that we're wreaking on the planet. I'm not a depressive person, but if you think of the way or the level of environmental destruction across the planet, and by that I include the loss of diversity as a result of declining sea ice in the Arctic, it's quite incredible the rate of change that is currently going on.
And could you give an example of a specific moment or loss in biodiversity from the melting sea ice? Just
I
curious
don't
for an
really
example.
want to talk about polar bears and fluffy things. I'll talk about Antarctica. We all love penguins. I have a real problem with Gentoo penguins. They're like... all I'm saying is that some penguin species, Adelies particularly, like sea ice and permanent sea ice, and they thrive in that niche. And Gentoos are more like farm animals that will colonize anywhere in Antarctica.
Interesting.
And what's happening as the sea ice declines down the peninsula, there are areas that were big Adelie colonies, and they've had to give up and migrate southwards, where it's colder, where there's more sea ice, and that territory has been given up to Gentoos. That's been documented across the peninsula for the last 30 years and is an ongoing process.
Wow.
So a complete sort of demise of a species of penguin that thrives in cold conditions to another type of penguin. You might think they're all the same.
They're not.
But they're not. But that's a very good indicator of actually, here's a very direct consequence of what's changing in terms of that system.
And a bit tragic, honestly, but yeah, thank you. I'm glad we were able to explore a bit on the penguins. And any thoughts now moving to our human guests and society in general, what the effect is on society at large? No pressure.
Wow. I study ice sheets. As I've said, ice sheets lock up. They're these frozen terrestrial reservoirs of water. They massively interface between the atmosphere and the ocean, and we, for want of a better word, we screw with them at our own consequence. Greenland contains enough fresh water to raise global sea level by over 7 meters. The rate of change of the Greenland ice sheet and the loss of that ice sheet that I'm seeing at the moment, like only 20 years ago, it was in equilibrium. It was an ice sheet that enough snow landed on it that equaled the melt and the icebergs coming off. It was a bank balance that was healthy. Like most bank balances these days, especially national ones, it's in deficit. And that deficit means the loss of this reservoir of frozen water on land, and it ends up in the ocean. It is global sea level rise. And all I'd say is we seem, with the IPCC and how we inform politicians, to put a massive trust in fairly basic models of how this system is working, particularly the ice component in it and how it interfaces with the ocean and the atmosphere. And maybe, if you think back to March last year when we were trying to predict what was going to happen with the pandemic in Britain, and that we'd all be fine and we'd all get herd immunity. These models, without data to constrain them, are perhaps a little bit complacent. And that's my real worry. I did my PhD in Edinburgh University on high-resolution modelling of ice sheets and glaciers to climate warming. And even back then, I saw a massive problem with the models, and that was in the dark ages, honestly. That was the last millennium when I did that. And the models aren't much better, honestly. They're unfit for purpose.
Right.
And that we feed these results, which sort of give us, maybe 10 centimetres or 20, or maybe at worst 40 centimetres of global sea level rise this century from ice sheets that I see from the data I collect, that is way out of sync with the observations. And that's what worries me a little bit, is that we have a little bit of a complacent attitude to it. But we love models, right? We love graphs
data
and numbers that give us certainty. Politicians love it. Everyone loves it because it tells us how the future's going to behave. But like most economic systems and the pandemic and everything, these models are
pushed aside.
crap.
Oh. We'll bleep that one out later.
Sorry.
But actually, it's quite interesting that you mentioned this, as it has been around. The data has been around. The science has been around. This is not new. We know ice is melting. We know sea levels are rising. What is new about recent research or in your observations, and why exactly should we be paying attention to it?
I think the key is that things are happening faster than forecast. I don't want to spend time battering models. They're the main tools that we have. But if they're unconstrained, there's not enough data in them, and the processes aren't in them, then they kind of become a little bit of a smoke and mirrors in terms of what's going on. And I'm very worried, I suppose, that this last AR6 IPCC report is just a little bit tame and a little bit watered down. I'm not a catastrophist.
Yep.
I've always been an optimist, but I think I had a revelation in Greenland about 10 years ago. As I said, I grew up with textbooks that said glacial processes were these things that took place over centuries and millennia. The ice age that affected Scotland and the Northern Hemisphere was 100,000 years. So these processes were slow, but our observations indicate that these things are happening, like the climate forcing, the climate warming is occurring on a decadal timescale, like it's really happened in my lifetime. There's glaciers in Switzerland that I studied for my PhD that are now gone.
Completely?
Completely gone.
Oh my
and
goodness.
It's like, hell, that's tragic for someone who thought, I've got the rest of my life to study these things. And I'm seeing the same processes happening in Greenland and Antarctica.
Right.
These things are happening rapidly, and they're happening now. And I think that maybe, perhaps I should be a little bit angrier and a bit more urgent to the business leaders, industrial leaders, and politicians. But it's happening now, and if we don't act really to reduce emissions into the atmosphere, we're going to hell in a bucket.
Hell in a handbasket. So, do you want to?
Thank you. So maybe, Lauren, sorry to interrupt, but Ulan, your colleague Gail Whiteman asked me to make sure that you were talking about the Arctic melt bottle that she brought to the speaker room. So maybe you can conclude your remarks, and then we have a very important workshop happening next door on climate vocabulary that I would like that we finish here so that we can start on the other side. So if you can close, now that'd be wonderful.
Perfect. And to close, I'd just like to hear, really, we've had a bit of doom and gloom, so maybe what are you optimistic about? What do you want everyone to walk away from this week, from today, from right now, feeling and knowing?
Basically, we've got here, and the Earth's got here now. It is a resilient system. There are negative feedbacks that put things right. That doesn't mean we need to be complacent, but I think if we can stop screwing and geoengineering the atmosphere into a warmer world, which we haven't experienced since 60 million years ago. I think these processes are reversible. I'm not a subscriber that we are past the point of no return. What I see in Greenland is that every now and again, when we get a cold summer and a wet summer, climate is very variable. The ice sheet does respond to that in a healthy way and replenish itself. So these things aren't irreversible. Don't give up. Really, really, really push the message right now, because now is the time. We don't have 50 years to sort this problem out. We have to do it, in this decade. That's all I can say.
Thank you. Yep, and that was absolutely wonderful. Thank you so much for joining us. Perfect.
Sorry if I went on.